Okay, this is Dr. Morton. This is for Lab 2 in Micro 2, Spring 24. And what I want to go through now is I want to show you how to play with the PWM. So to do this, we're going to first import. We're going to bring up our MCU Expresso, and you can. So we'll do that right here. And here's my Freedom board, and then we have a little terminal window. So I went ahead and I brought up so we brought up our little we brought up the device manager, and we see it's on COM17. So then we opened up a terminal window, COM17, and there it is. And I've tucked it right up here in this corner. And then what we're going to do, we're going to import an SDK. So the first thing we do is import an SDK example down here in the project window. And we're going to use the KL25Z. That should already be set up for you. And we're going to do one of the driver examples. We're going to do the TPM. It's going to be a TPM example. And we're going to do the simple PWM right there. So we're going to finish. I think it lets us do it because it's going to bring its own name in. And we have the UART selected. So make sure you do that because we have to use the UART for this one. Okay, now we're going to open this program. It comes in open actually. And we're going to open up the source and we're going to bring it up so we can see it. And here it is. Now there's a couple other things we want to see here. I want you to also be able to look at two of the files. I want you to be able to look at the TPMC and the TPMH. And so we'll bring those. There's the TPMC and the TPMH. And now we'll go back here, and then we're going to scroll down. Now the first thing we're going to do is we're going to notice that we're initially going to use TPM2, and we're going to use channel 1. And then we're going to have our clock is this K clock, phase lock loop, frequency lock loop, select clock, and basically it's going to be the system clock. If we bring up the clock tool right here, and we make sure we have the right program set up here, which is this one. It's the only one I have open, so that makes it easy. And then we look at the so we have an external 8 megahertz crystal, and we have the phase lock loop engaged, and the phase lock loop is generating a core clock of 48 megahertz and a bus clock of 24, and the system clock is 48, but the clock that will actually go to the TPM is going to be the 24 megahertz clock. Now we do have a TPM setting down here, but that's inactive, and I'm a little confused about this, but anyway, the bottom line is it is going to use the system clock, and the clock it's going to use, I believe is the 24 megahertz clock, or maybe the 48 megahertz clock. It's a little confusing about that, but that's where we are. Okay, so I'm not going to mess with this. I'm going to leave this alone. But what I am going to use is the pins tool. And I'll go in here. I'm not going to actually change anything, but what I want you to see, there are two things set up, the UART and the TPM 2 channel. Now, the system has 3 TPM modules, TPM 0, TPM 1, and TPM 2. In this family of chips, they could have up to 6 channels in each module. But the way, 8 channels in each module. But the way this is set up, TPM 0 has 6 channels only instead of 8. TPM 1 has 2 channels instead of 8, and TPM 2 has just 2 channels instead of 8. So we're gonna leave it on TPM 2, but I want you to see. So I click here, and notice it says channel 1 and channel 0. That's because TPM 2 has 2 channels. If we get out of this and we go to TPM 0, which is here, and we click on that, notice it does have 0, 1, 2, 3, 4, 5. It has 6 channels, and it tells you how many pins you can route it to, which is really nice. It also has a clock you can use, and it has a trigger. And but we don't need the trigger. It's just going to be continually triggered, and our clock's going to be the system clock. All right, so we'll ignore that. We'll go back here. So notice we have channel 1, and then if we click on channel 1, we have these options. Initially, we're going to do PTB 19. Okay, so that says done, done, and now if you notice down here, we have LED green is connected to channel 1 of TPM. We don't have to specify the direction because the TPM channel itself is going to control that. Okay, so with that, we're going to go ahead and we will set up here. We have this done, and we'll go ahead and update the code. Now, we don't actually have to do that because that's how it was set up by default, but we'll go ahead and just do that anyway. Now, I'm going to go ahead and I'm going to check a couple of other things here. One of the things that so we have an initial duty cycle. We set some of the initial things. So let me just go through a little bit. So the first off, TPM config. So we're gonna config TPM. Now, if we wanted to change some of these things, we can use this TPM info pointer using the dot reference, and we can reference any of the selections in the TPM config. And TPM config, it shows up here, I guess. Let's see. TPM config. Let's hang on a second. Okay, so if we go into the header, the TPM, the freescale underscore TPM.h file, here's our TPM config, and so it's basically a structure, and here's all the things in it. So it's a type def, and the tag is TPM config, and it includes the prescaler, the global time base, the trigger, this doze thing, the debug mode, whether it's active in debug or not. Again, the reload trigger, the stop on overflow, and start on overflow trigger. Some of these things, and basically these are defined as default values. And I'll show you where that is then. That's in the C file. Here they're all set up. So prescale is, there's an enumeration of all the prescalers. And again, we can look here and we can see that enumeration. There's a divide by 1, 2, 3, 4, all the way up to 128. And all these are just equivalent to numbers. Divide by 1 is 0. It's basically 2 to the 0, 2 to the first, 2 to the second, third, fourth, fifth, sixth, seventh. And anyway, so we're going to use initially a divide by 1, and then so we're going to so here we're basically creating an instance of this structure, and we're calling it TPM info. All right. So now if I wanted to change something in TPM info, the structure we've created for this program, I would just type in TPM info, and I'd set it dot, in this case, prescale. So here are all the choices. One of them is prescale, and so I'm going to I'm just going to go ahead and do prescale, and then we'll set that equal to this enumerated value here, which is the 128, which actually equivalents to this actually, if we hover over it, it equivalents to 7. So that's 2 to the 7th, basically. But I'm going to comment this out right now because I'm not going to use it till later. All right, and then we also have the TPM parameter, and so that gives us some parameters of the channel. And then we also have this one option here, this level select, and that's that's PWM level, and this is KTPM low true, which means when it's it basically toggles the output. So your PWM signal can either be normally high and go low during the active pulse, or it can be normally low and go high during the active pulse. And so we're going to do, so that's what we're doing. Okay, now this we're going to do this because that's really interesting. Yeah, so because our we're going to do low true because our actual signal is first we're going to control an LED. In the case of the LED, we want it low when it's on and high when it's off. So we're going to do low true for that reason. Now this also is another enumeration, and so we'll look at there's two other possibilities. Basically, it's off. Let's see where this actually comes in here. No signal, low true, high true. And so later on we may need to change this to high true. We'll talk about that. I may just go ahead and get this set up and we can talk about doing that, because I actually think that's a very interesting facet here. So we'll do that, and we'll go back here. And so I'm going to copy this. I'll do a little high true. So that we could substitute that in later on if we want. Or maybe what I should do is copy this, and then we'll put it here, and then we'll put in our high true here. Oh, that didn't work. Here we want. Well, yeah, we'll do this. Okay, and then we'll get rid of this. But we will comment this out. So that's for servo, and this is going to be for a common anode LED. We want low true because that'll turn it on. Okay, that's all good. And then so that fixes that, and so we'll come back and change those things later on. And I guess so we'll just leave that because the default's 1, so we'll just leave that like that. Okay, but these don't necessarily have defaults. All right, now there's one more thing. So then we're gonna do all these things, and then we're gonna so the channel number, and so that's defined up here. Channel number, we're gonna use channel 1. Okay, and then power level or PWM level, that's just the initial value for our duty cycle, and it's and it should tell me what that is. Oh, it's power level. It's low true. Okay, so that's where we actually set that. Yeah. Okay. And okay. This is just the default setting. We're changing it and then resetting it here, and then okay, got it. Okay, and then that's the initial duty cycle. Now, so the first thing we do is call the board and NIPS pins. That sets everything out for our UART and our PWM channels, and then we're going to get the clock set up and running, and we're going to set up the debug console so we can write out to the terminal window or whatever, and then we're going to set the clock source, and the clock source is going to be it's going to be this K clock P phase lock loop, or phase lock loop, frequency lock loop, cell clock, and that's going to be this one. So it's driven by this external crystal, and if we click on it, it should tell us clock set, and so that should be if we look up here in our, let's actually, let me copy this and I'll search for it. That makes it so much easier. So not the, where is our, yeah, get, no, clock. Yeah, so clock, this one, here, let's do this. We'll look at this here, and then we'll go up here, and we'll go up to the beginning, and we'll see if we can find it here. Okay, then maybe here. And we'll do the find here. Okay. Great. Okay, so actually this is in a different module we haven't brought in, but if we just hover over it, you can see, sorry, if we just hover over it, it opens up this, and we can open it, you can see it. So it's a static inline function, and it just does this. It takes the system integration module register SOPT2, and it sets it equal to that register ANDed with this stuff ORed together. And basically these are masked, and I think this is, I think it turns on the clock and sets the module up to work. Anyway, we'd have to go into the system integration module, the register, to see that. Okay, so I just pulled this up so you could see. So this refers to the system integration module. What is it called? System option register 2, and it's basically a way to turn on the clock to the UART and to the TPM. It's also it also picks the source of the clock for the TPM. Well, this picks the source of the clock for the TPM module, and this is the clock it picks, 0, 1, which is that source. So let me turn this off. So you can see it's 0, 1, which is the MCG phase lock loop clock, or the MCG frequency lock loop clock, and so that's the one that's driving the system clock. So basically, it's a system clock. Okay. Yes, I think that's correct. All right, and then we're going to print out some stuff, and then we're going to get the default configuration using the TPM info. Now remember, what we may come back here and do later on is we'll be able to change this TPM info. Let's see, I don't think I did that. Yeah, I did. So at this point, we can change the prescale to 128, and then when it does this, when it TPM default config, then it'll initialize all those settings to the values that we've set. But I may have to put this down there. Let's see. I think I do have to put this down there. Yeah. I think. So we'll put it down here then. Yeah. No, I think I have to put it up here because this is where it's going to be. So yeah. All right. Well, let's make this work. Okay. So anyway, I haven't really changed anything. I've just gotten ready to change things in a minute. Okay, so let's go ahead and compile it, and then it finds this thing, and we're going to compile it. And what we'll do, then we have our COM window set up here, and so then it's going to print some messages here, and we're going to be able to type in a single digit. Now, if you look at this, one last thing before I hit go here. So here's what it's actually going to execute. It's going to print this stuff out, and then it's going to wait till we type a character. We can type 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to import that ASCII value as the get character function is going to do that. We're going to subtract 30 hex from it, and the reason we're going to subtract 30 hex is because 0 is 30 hex. So if we type in a 1, then our get character value is going to be 1. If we type in a 2, it's going to be 2, and so forth. So, and then we're going to print out that value, and then it's going to set the duty cycle. As long as it's greater than, if it's greater than 9, we'll keep doing this. But if it's less than 9 or 9 or less, then we'll drop through and we'll update the duty cycle to get character value times 10. And so a 1 will be 10% duty cycle, a 2 will be 20%, a 3 will be 30%, and so forth up to 90%. Okay, so let's see what that looks like. So now if we do this, we should see the green LED here just a little bit. It's a little hard to see. Let me turn off the light. And it's kind of hard. Yeah, now you can kind of see it. Oh, I can see that's probably part of it. Yeah, now you can see the green. Okay, now you'll see if I'm in this window over here and I'm typing in values, so if I type in 0, it should go off. If I type in 1, it's dim, 2, it's brighter, 3, it's brighter, 4, it's brighter, 5, 6, 7, 8, 9. And then let's see what that looks like on the oscilloscope. So to do that, I'll just hook it up, and then I'll bring that up. So hang on 1 second. Okay, now because the pin that drives the green LED does not appear on any of the headers, I had to solder a little wire on to the resistor, the current limiting resistor for that, which I got off the schematic. And there actually was a tie point on the bottom, but I popped the tie point off, unfortunately. So I had to solder to the resistor. All right, now, if you look at this, here's my scope tracing. And right now I'm in a 0 mode, but if I go into my terminal window here, you can see right here, and I click in here, and you can see my cursor then there. And if I type in a 1, we'll have a little bit of a dim. And notice the on my cursor, on my oscilloscope, we have, well, first off, notice we're operating at 23.99998 kilohertz. So 24 kilohertz, which is 1,000th of the bus clock, and that's because we're the way the clock is set up, that's what we get. Because we're using a 24 megahertz bus clock to get this, and yeah. Okay, so here's our value now. If I hit say 2, you can see we have a little more downtime. Remember, the downtime determines the brightness. So in 0, we have no downtime. In 1, we have a little bit. 2, we have more. And you can see the brightness continues to increase as we do this. Brighter and brighter and brighter and brighter. And now we have 90% of the brightness. I don't have a setting for full brightness. And then if I go back to 0, it goes off. Okay, so, and that's because we're in a 10% duty cycle gives us 10% down because we're in true low as opposed to true high. And so if we change that, maybe I'll go into the code and change that right now, and we'll recompile. That'll be a good thing to do. So let's do this. So I'll go over here in the code, and let's see, where do we set that true high? I forget. So I think I set it up here for true low. Yeah, so here's true low, and here's true high. So I'm just going to reverse this, and now I'll put the, yeah, perfect. Okay, so now I'm just going to compile it again. We'll run it, and you'll see that should flip around. It'll be just the opposite. Okay, and we'll run it. And, yeah, now you see it's opposite. So now I have a very bright LED. If I go to 9, sorry, it wasn't in the thing. I put a 9 in my code. Don't do that. That is always what you don't want to do. All right. So if I go into the window, click in it, put a 9, now you can see it goes dim. A 0 turns it off. A 0 now turns it full brightness, and then a 9 is dim, 8's brighter, 7's brighter, 6, 5, 4, 3, 2, 1, and 0. And then that's full brightness. So now I don't have any way to completely turn it off. Okay, now, yeah, that makes total sense. Okay, very good. Okay, now we're going to do things, we're going to make a change, and we'll do things just a little bit differently. What I'm going to do now, I'm going to get out of my debug mode so I can compile it again in a second. Okay, so the problem is, what we really want to do with this is drive a pin. Now, what I really want to do is I want to drive a pin on the actual tilt table. So we're going to use the KL25Z in the tilt table, but we have to change some things. So one of the things we have to change is the fact that that the pin on the tilt table, the 2 pins that are on the tilt table that are connected to the servo outputs are PTB 0 and 1. So we have to do things a little bit differently. So let's take a second here. Okay, so I went to chapter 10, which shows our multiplexing table, the KL25Z multiplexing pin assignments, and now we're going to go through and we're going to look at this and see if we can figure out a good where we can find PTB 0 and 1 driven by the TPM module. Now I happen to know that they can be because that's how we set it up. All right, so I'm going to scroll through this, and so I'm going to look at B, and I think it's 46, 47, something like that. So where's PTB? Yeah, okay, 43 is B0, 44 is B1. So let's look at this. TPM1 channel 0, it will do PTB 0, and TP1 channel 1 will do PTB 1. So let's do TPM 1 channel 1 instead of TPM 2 channel 2. All right. So now I'm gonna we'll get rid of that, and so let's look at our code. So up here at the beginning, we selected TPM 2. So if we change this to TPM 1, that'll be good. We're still on channel 1, so that's good. Now the other problem is we have to reassign the pin and change the TPM. So for that, we're going to do the pins tool, and we'll set up the pins tool. So here, we'll just go in and we'll uncheck that. Well, actually, what we want to do is unroute all, and so we're done. So that turns that off, and now we'll turn on TPM 1, channel 1, and then we want to go to PTB 1. So we'll check that one. Done, done. Now we have to update the code, make sure our window's set correctly, and we do that, and it's going to run in the background for a little bit and then be done. Okay, now that's done. Now the only other thing we have to do is we've already changed it to the high true, so that's more what we want for the servo. Although truth be known, for this little demonstration, we could kind of work it either way. But all right. And then, so we've got that checked, and then now we need to change the prescaler to 128, and we need to make one more modification, and that is down here. Yeah, that is down here. This little this command here. TPM setup PWM board TTM base address. Now, if we look at this, we want to look at this function. It's going to do these things. Number of channels. We're only doing one channel. We have the base address. We have the pointer to the TPM channel PWM signal parameters, and but this also sets the frequency in hertz. And so after we change the prescaler, we can now change this one. We can change this into 100, and that should give us a 100 hertz signal. Now we'll verify that when we get the scope on it. And I think that's all we have to do. Let me just see if we can compile it without any errors, hopefully. And it's going to find the board. Now I've switched the board. Let's see. Yeah, I've switched the board to, let me change this camera. I'll turn on the, not the scope. Well, we'll turn on the scope in a second here. Actually, we won't. Let's see. Where is my other camera? I don't know. Let's see. I think it's not dock. That's that one. Oh, I think maybe I need to modify this one. Yeah, I'll change this one so that we have the a different camera. Okay, so now you can basically see here's the setup for the. So I'm taking the board I was using. I'm going to put it over here, and then I'm going to take my scope, and I'm going to hook the scope up a little differently. So we are using PTB1, and I actually do have this set up so I can connect it directly to PT1, hopefully. And then I'm gonna just do the. We'll just do this. We'll just ground this to this, and then we have our servos plugged in. I forget which one comes out on which pin, so I think the channel 1 is going to be my X, but we'll see. Could be channel 0, and I'm always a little confused. We make sure we plug them in right with the ground to the ground and the signal to the signal, and then that should be all set. Okay, and now we actually have a signal on it, but let's go ahead and we'll set this, and then I'm going to put the camera over here so we can look at. We'll be able to see the table move when it does. Let's see. Oh, I changed my sound. No, how did I do that? Oh man, I changed my signals. Okay, so let's. Yeah, that's what I. Oh yeah, that's okay. That's what I want. Okay, yeah. So maybe. For some reason, it's not doing it. Okay, let's turn it off. That's me. Let's turn the document camera off. That's that. It's not working. Let's do this again. So document camera. We'll do the. Okay. Now. Okay. Let me get it working. Okay. So now we're going to run it. I'm going to hit the run. And you can see the you can see we get the information here on our screen. We'll click on this, and now the only other thing I need to do is hook the battery up here, so that we got power, 6.5 volt power to the servos. Okay, and then yeah, and now if I click in here, I should be able to hit. 1 and 2, 1 and 2, and let's see where's our scope. Let's put this on. I think we may have to do this one down. And so let's see. So right now we don't seem to be. Yeah, it doesn't seem to be doing it. Nope. Okay. we're still not seeing the signal in the scope. So let's disconnect this. We should be seeing the signal at a minimum. We're not. Okay. Okay, so we finally got everything all set. We now have switched to TPM 1. We've changed the port. Let me show you on the pins tool again. I think you saw this already. So we're in TPM 1, channel 1, and PTB 1, which happens to go, it goes to the Y axis on my table. I think that's the same for yours. So I'm gonna cancel this, go back to this view, and then we're all set. We're ready to run. We've compiled it, and all I need to do then is we go over here, and you can see on this clock here, hopefully, on this no. Okay, for some reason that one's not working. Okay, the scope's good, the terminal's good, video capture, dock. This is the one I want to change. And I want, so let me, okay, now we're all set. So here's the, let's see. Yeah, no, yeah, maybe. Anyway, so here's the window. You can see the tilt table here. And, oh, I'm not in the window. Yeah, good. Notice where I'm changing the PWM signal, and if I measure this, if I measure, so simple. So the you can see that my frequency is 100 hertz. So if I want to measure, let's see, I should be able to put cursors. Let's see if I can get this right. So measure, and then I think you can do source C1, and then no, I don't want to change that. Cursors. This is what I want. Yeah. So I want to move. I want to measure. Say. So I want to. So here's the period. So we'll go from here to the cursors, and then and then I want to move the other cursor. So X1, X2. Okay, so I need to go. So I'm going to put X2 here. Oh heck, I'll put X2 here. The start of this period. Oh, so remember it is center. And then let's see. I want to go to. Yeah, let's see. Cursor type. Cursor X2. Cursor X1. And then now I'm going to move X1. So now we should measure. So what we're seeing is it's 10.15 milliseconds is the period. It should be exactly, but my cursor's probably just off a little bit. Maybe I'll let me do the cursors again, and I'll do X1, and that was it. And now I'll do X2. I'll adjust a little bit. .05. So it's really close. And then let's measure how much the actual pulse is. The pulse is 1.95 milliseconds. So it's right at 2. And then if we change it, that was, if we do this, that was the, and then if we go to 9, now that's the other side. And now you can see we have, it's right at 1 millisecond, 0.9. Okay, and so now we're in, looking at it, we're in clockwise rotation, and when we go to 8 rather, now we're in counterclockwise rotation. Clockwise, counterclockwise. All right, so that's good, and I think with that we're going to close the video.